Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about normality. The concentration of a solution can be expressed in a number of different ways. A previous video talked about how we can use percent as a way of indicating the concentration, and another previous video talked about how we could use molarity to express concentration of a solution. Another unit that you might encounter is normality. And normality of a solution is the number of gram equivalents of solute contained in 1 liter of solution. Capital N is used as a symbol and it means equivalents per liter. This method of expressing concentration is very similar to molarity. With molarity, we were expressing moles per liter. And in order to do so, we needed the molar mass. This is similar, except we're going to be using equivalents per liter. And in order to do that, you need to know what the gram equivalent weight is for the element or the compound you're working with. It's going to be the mass that will combine or replace 1 mole of hydrogen. And it can be calculated. Gram equivalent weight is equivalent to gram molecular weight, which we've talked about as molar mass, divided by the charge of anion or cation, or number of reactive hydrogens. My expertise is in math, not chemistry, so what I want to focus on is how we express the concentration as normality, or if we're given the concentration as normality, how we express it in another unit. So let's take a look. So I've listed 3 particular substances, and we'll use those in our examples. And with each of those, I've listed the GMW, the grams molecular weight, as well as the grams equivalent weight. Now you'll notice that they're the same for sodium chloride and for sodium hydroxide. In those cases, our charge is 1. So we're taking this and dividing by that charge. If the charge is 1, then they're equivalent. However, with phosphoric acid, if we were to divide this number by 3, which is the charge, we would get this value. So you're always going to see a relationship between these 2 values that is either equal, or your GEW will be 1/2 if the charge is 2, or 1/3 if the charge is 3, 1/4 if the charge is 4. Let's take a look at expressing concentration of a solution as normality. There are 250 grams of sodium chloride per liter of solution. What is the normality of the solution? So normality, remember, is equivalents per liter. So always start with the amount of solute, 250 grams, in the amount of solution, 1 liter. And in this case, we don't want grams per liter, we want equivalents per liter. So we want to replace grams with equivalents. So grams going to go in the denominator so that it will cancel, and we want to replace it with equivalents. The value that we use to do that, there are 58.443 grams in 1 equivalent, so 1 equivalent is equal to 58.443 grams. Grams will cancel, and we're going to take 250, divide by 58.443. When we do that, we get 4.3 equivalents per liter. Or you might see it expressed as 4.3 capital N. And when you see that capital N, understand that it means equivalents per liter. Let's take a look at some more examples. In our next example, we're given the concentration of a solution as a percent, and we want to express that concentration as a normality or equivalents per liter. So let's start with what percent concentration means. 1.5% means that there are 1.5 grams of solute in 100 milliliters of solution. We want to change grams to equivalents, so we're going to use the GEW of phosphoric acid. So we know that grams needs to cancel, so we put grams in the denominator, replace it with equivalents, and we know that 1 equivalent is equal to 32.665 grams. That will cancel. We also want to change our denominator to liters instead of milliliters. So if milliliters is in the denominator, to cancel it, we put it in the numerator. We replace it with the unit we want, which is liters. These two have to be equivalent, so you can either go 1,000 milliliters in 1 liter, or you can say 1 milliliter is equal to 10 to the negative 3 liters. Either option will give you the same result. So now milliliters will cancel, so we're going to have 1.5 times 1 times 1, divide by 100, divide by 32.665, divide by 10 to the negative 3, and when we do that calculation, we'll get 0.46. So you can write that as equivalents per liter, or 0.46 capital N. In our next example, we're given a solution of sodium hydroxide that has a concentration of 4 equivalents per liter, and we want to express this as a percent. So what I'm going to do is start off by changing it to grams per liter. Because when you're dealing with percent, you're talking about grams per 100 milliliters. So let's start with converting it to grams per liter. So 4 equivalents per liter. And we want to replace equivalents with gram. So equivalent goes in the denominator so that it will cancel. We look up our GW for sodium hydroxide. It's 39.997 grams per 1 equivalent. That will cancel. When we do our multiplication, we'll get 160 grams per liter. Same concentration, just expressed in a different unit. Now we can use this to change to percent. Percent is how many grams are there in 100 milliliters. So we know we have 160 grams in 1 liter, which is 1,000 milliliters. Percent, I want to know how many grams are there in 100 milliliters. Percent always means per 100. We cross multiply. We're going to divide by 1,000. And X is 16 grams per 100 milliliters. Therefore, our concentration will be 16%. Our next example gives us a solution of phosphoric acid with a concentration of 3 capital N, which is equivalents per liter. Convert this to molarity, which is moles per liter. So in order to do that, let's write 3 capital N as 3 equivalents per liter. So 3 equivalents per 1 liter. Let's go to grams per liter next. So we're going to change from equivalents to grams. This is what we're going to use. We know that there are 32.665 grams in 1 equivalent. So that will allow equivalents to cancel. We'll be left with grams per liter. Then we want to go to moles per liter. So we're going to change or cancel grams. Grams is in the numerator here. We put it in the denominator, and we're going to replace it with moles. So we take a look at this number. We know that there are 97.994 grams per 1 mole. So now grams will cancel, and we'll be left with moles per liter. When we do the calculation, 3 times this number, divide by this number. When we do the calculation, we'll get 1 mole per liter, which we can leave expressed as that, or we could express it with a capital M, which means moles per liter. We've been doing examples where we're changing the concentration units of a solution from percent to molarity to normality and so on. Now let's do an example where we need to find the amount of solute to make a certain amount of solution. We're asked to find out how many grams of sodium chloride are present in 500 milliliters of a 2.5 capital N, which remember is equivalents per liter solution. So my first step is to change equivalents per liter to grams per liter. So in order to do that, we need to use this value, and we're getting rid of equivalents, replacing with grams. 58.443 grams per 1 equivalent. We'll get 146.1 grams per liter. That's our concentration using grams per liter. Now we can figure out how many grams we need in 500 milliliters. Let's change 500 milliliters to liters. We're going to divide by 1,000, so it's 0.5 liters. Whenever I'm doing questions where I need to find the amount of solute or the amount of solution, I find direct proportion is the easiest. So I know that with this concentration, there are 146.1 grams of solute in 1 liter of solution. So I want to know how many grams of solute will be in 0.5 liters of solution. We cross multiply, 1 times x will equal 146 times 0.5, which would be 73.05 grams. My next video is going to be on concentration of a solution when you know the specific gravity and the assay or the purity of the solution. We'll see you then.